Welcome to Brain Vision.
In this problem, we're going to do parts A and B together. So first, I'm going to start with block A and draw the free body diagram. We have a tension force, tension between A and B, pulling it up. And we have mass of A times gravity pulling it down. We also have an acceleration pulling it up. And so if I apply Newton's second law in the y direction, I can't set it equal to 0 because we have an acceleration. So this full equation implies that tension between A and B minus mass of A times G is equal to mass of A times A. Solving this for the tension between A and B, I get mass of A times A plus G. We know what G is, A is given, and mass of A is also given. And so this is 4 times 2 plus 9.8, which is equal to 47.2 newtons. Now I'm going to do a free body diagram for B. And so if this is block B, I have a tension between B and C pulling it to the right. I have a normal force upward. I have two forces to the left. One is tension between A and B, and the other is friction force, kinetic friction force, which is equal to that. And then I also have downward gravity, which is equal to the mass of B times G. So the sum of the forces here in the y direction does equal 0 because there's no acceleration in the y direction. This implies that N minus mbg is equal to 0. So N is equal to mbg. Now I can use this expression here to solve for the friction force. So that means the friction force is equal to mu sub k, which is given to us as 0.25, times N, but N is mb, which is 12, and then G, which is 9.8. And so this is equal to 29.4 newtons. Now I'm going to do sum of the forces in the x direction on block B. In this case, we can't just set equal to 0 because there is an acceleration in the x direction. So this equation implies that tension between B and C minus tension between A and B minus friction force is equal to mass of B times acceleration. I can solve this for the tension between B and C, and I get tension between A and B plus friction force plus mass of B times A. At this point, we know all of these. We found this on the previous page. We just calculated this to be 29.4. We know the mass of B and we know A. And so plugging in all our knowns, we get that T of BC is equal to 100.6 newtons. Now one more free body diagram. This one's for C. And so I have the mass of C times G pulling it down. I have an acceleration downwards. And I have tension between B and C pulling it up. And so the sum of the forces in the y direction is equal to mass times acceleration in the y direction. And I'm applying this for block C here. This implies that mass of C times G minus tension between B and C is equal to mass of C times A. We can solve this for the mass of C, and it's equal to the tension of BC over G minus A. Plugging in these values gives 12.9 kilograms. And that's the answer to part A. But it turns out that part B is asking for the tensions between the ropes, and we found that at various points throughout the problem. For instance, TBC is equal to this value, and TAB is equal to this value. And so we have completed the problem.